Our objective today is to clear chapter 1, and then if can, we go try to clear chapter 1, because chapter 1 is a very big chapter. Okay, so before we start, we'll brief you how to get all these formula that you see on the screen here. A equal to tangent component acceleration plus normal component acceleration. Okay, so again, we are dealing with vector. So vector, again, you have magnitude and direction. AT is magnitude, UT is direction, plus AN is again magnitude, UN is a direction. Okay. Okay. Right. So if the object move in a straight line again, it's fall under tangent direction. Okay. Right. Now what happened? All these before these are all two-dimensional. It only move in on the piece of paper. It's only move on the plane. So it's a 2D. So you only draw normal tangent. What happened if the object move in a three-dimensional motion, right? So when you move in three-dimensional motion, you add in one more axis, we call it B. So the gray area here is a piece of paper like what we covered previously. You have a normal and tangent direction. But when you talk about three-dimensional, then you have one more component, your Z component. But in this case, because you want to separate from the Cartesian plane, we want to separate from linear motion, we don't use Z, we use B. Okay, of course, you can use Z, but you might confusing yourself. So in this case, we use B. Right? So this object move from the left to the right. Left to the right, it's moving a curve. So by looking at the curve, you know where is the center of the curve. Must be always pointing in. That is your normal direction. UN. This is direction. Huh? So and then O center, starting point, second point, and so on. Okay. So on the vector, because all these are vector. So again, go to Appendix B, go and look at it, how to deal with vector. Huh? So back to the slides. So how do you calculate vector B? You know the vector, you can use right-hand rules. So how to calculate vector B? You take tangent cross normal, right? You use right-hand rules, left, right. So B going up, you open your finger, B going up. Where do your finger cross? Anti-clockwise. So you put your finger, go up. So U, a T, cross to N. You get B. Okay, right-hand rules. Same. How you get N? And you, again, right-hand rules. Your thumb is the one that you want to find. So UN pointing in, then watch your finger, where your finger curve. So B cross to N, B cross to T. Okay, so this is how you find. But the mathematics working, you need to refer to Appendix B. I will not go deep into how to find cross products. Okay, that is your mathematics lecturer job, right? Okay, so these are the procedure to help you, some guideline to help you when it comes to analysis for curvilinear motion. So first, when you see there's a curve in the question, straight away draw tangent normal axis on your free body diagram. Okay, so if you're linear, you draw x, y axis. If you curve, you draw tangent and normal straight away on the graph, on your drawing. Okay, so and then point your origin. Curve must be origin one. So your coordinate system must come with the origin O, and where is your normal and tangent. Okay, so that's the first step. So How do you do? Normally, they give you a question, an object. It will tell you an object move to left or right. So straight away, you draw the center. Normally, question will give you one center. Then it will tell you this object move left to right. Okay? Sometimes the question will confuse you, will give you X and Y. But don't confuse by the X and Y. Straight away, draw the origin, draw tangent, normal axis. This is the first step when you solve collinear motion. Then you mark the direction of positive, negative for normal. So if this object moves from the top to bottom, the tangent to the right is positive. Going inwards to the center is positive. So that when you do calculation later on, you know at the end you get negative, then you know it's another way around. You are dealing with engineering dynamics now, not statics. Dynamics, during statics, it moves in one direction only. It move along the way. But when it comes to engineering dynamics, the particles can move and then U-turn one. So at that particular time, it not necessarily continue to move in one straight line. Yes, it moves in straight line, but the motion can be U-turn one. It can be moved backwards because you're dealing with quadratic equation, exponential equation, and so on. Okay, no longer linear equation, not only linear equation. So something like that, right? You draw tangent normal graph on your solution. Then reminder, velocity always tangent. Again, it's important. So because when you solve collinear motion, you don't know direction, then you are lost already. You start to panic because there are so many equations you need to memorize. When it comes to tests, you might confuse yourself. Actually, you know one, but you confuse yourself. So the drawing that we mentioned just now will actually help you. So these are magnitude, velocity, you use v equal to ds dt or s dot. So something like that. Okay. Then the velocity, this one, if this velocity change with time, become acceleration. Make sense? Velocity, this point to this point, this is a second v. So you take this v, differentiate with this v, then you get acceleration. Okay. So again, these two is important. So how you find acceleration? Recall definition of acceleration in tangent. You differentiate velocity with time. Then there's one equation which is a ds equal to v dv. This you derive, you freeze the time. You call the definition of acceleration. A equal to ds dv dt. V equal to v equal to ds dt. You freeze the time. You rearrange the time together. Equal left hand side equal to right hand side. Rearrange, you get this one. Okay. So that's why in the beginning I always emphasize which are the important formula. You will keep continue to recycle only. Okay. So then there are three more equations that you can continue to use from the previous section. S equal to so and so, V equal to so and so, V square equal to so and so. Only one condition is that it must be constant. Okay, what I mean by constant? There's a rate, velocity is changing along the way. But velocity do not change, constant. What is the value of your acceleration? 0. So no, you can continue to use this equation. You just need to know that your A is 0. So you cancel out all these terms. Then be careful when your V there's one question in the, I think your example number 1 in your tutorial, for your tutorial question, when your velocity is not constant, then be careful. Okay. Okay, so again, these 3 equations normally when you use, normally you when you see the question asks you the object go up and go down, throw up, go down, then these 3 will sure come out one, because it's only deal with gravity. Okay. Normal acceleration, as we mentioned, there's one formula for normal, v squared over rho. Rho is the radius of the curvature. Okay. Okay, so this is what we mentioned. Memorize this. This is the equation for today. Rho, new equation for today, but important, this equation won't be given in your assessment. 1 plus dy dx square 3 over 2, and it's a positive value of your dy square dx square. This one, when you need to use this one, when you want to solve for acceleration equation, when you want to find your normal direction for your acceleration. Normal acceleration is v squared divided by rho. Sometimes your rho won't be given, especially you come to final exam question. So don't panic. Oh, sir, I don't have this one, cannot do. There is a hidden equation that I show you on the screen. This will carry some marks, normally 2 marks for this equation. If you don't write this one out, means you don't know or you don't understand. Okay, so this actually tests your differential skill. dy dx equation, this one differentiate 1 time, this one 2 times. And there is an exponential component here. It's a cube and square root. So when you press calculator, be careful on your notation, especially bracket. I will recommend you calculate this one first. Then you calculate the whole thing. You get the top one. Then you solve for the bottom one. You take top number divided by lower number to be safe. Because sometimes your calculator might mess up the calculation. You know how to solve, but when you press, sometimes you forget one bracket, you forget to close the calculation, then mess up your answer. Let's look at one example, how we apply what we learned so far. So you are given a skater. So this skater is skate from the top of the hill and then it land on the snow. Right? So given you one pathway for this skater. So skater reach point A along the parabolic path. It gives you parabolic path. Of course, when you mention parabolic, it will give you one equation. Y equal to 1 over 20 x squared. Again, when you see curve, you're given equation y equal to something. Remember this equation. There's a reason why it gives you this equation. Because it's want you to find the radius of the curve. And this is a dy dx for this one. It want to test you whether you know to find the radius. Okay, so there are some hints inside the question. So have the speed of 6 meter per second, which increasing at 6 meter per second square. This is 6 meter per second is velocity. Increasing at 6 meter per second square. This is acceleration. Determine the direction of its velocity and direction and magnitude of its acceleration. You need to find both velocity, direction, and acceleration component, right? At that instant. Ignore the size of seeker, the object at this moment. Okay, so how do you do? First, you look at the object. Although it gives you x and y, there is a distance given, and that particular time, the object was 5 meters above the ground, above the reference ground, and from the finishing line, finishing point, 10 meters. Okay. First, again, on you copy the drawing, copy the picture into your solution. First, you draw normal tangent direction. Okay. First, draw normal tangent direction. Where is the direction of normal? Always the curve point inside. Tangent always follow the object direction. This object from the top to bottom, so it should be pointing down, not up. Okay. Then your VA was given is 6, and then there is an angle. There is an angle theta here. This angle theta is at this point referring to x. Yeah. Why we need this theta? Because we need to tell the direction. Okay. This theta is along your tangent axis. It's actually overlapping your tangent axis. Because we look at that particular time, we freeze the time here. Then we put in normal and tangent axis. Okay. We start to do coordinate system. You put all this on your solution. Okay, you represent this person as a dot or a cube or something. Okay, then we start to do analysis already. Velocity, always tangent. Do not go into normal. Velocity always tangent to the curve. So you know your VA already. Okay, so normal VA 6 in the question, it gives you already 6 meters per second. Okay, then it's an angle there, and you're given one equation, y equal to 1 over 20 x squared. So you do differentiation. dy dx, you get 1 over 10 x. Makes sense? Okay. So you need to do another one, right? To find the radius. You need double differentiate. Okay. Nicole, what is the double differentiation? Dy square and x square. How do you get? I'm asking you this one. When you do double differentiation, do you understand what you're asking? You understand? Dy, dx, and d square y and d x squared. You understand this one and this one or not? Your dy dx, you get 1 over 10x. What is the answer for the square y dx squared? Okay, I'll give you a mathematical question, Nico. Y equal to x squared. Y equal to 2x squared. Dy dx, what did you get? you get x. Then you're not fit for this module. You have to go back to your mathematics module. What is the formula for dy dx? N minus 1 n. So what do you get? Y equal to 2x squared. What do you get? 2x. Oh my God. Okay, Nico, your homework. Go to next class. You need to submit 10 exercise. Submit to me. 10 question. Go to your calculus textbook. Go and find differentiation. Go and do 10 question. Find dy dx question, the double differentiation question. Go and find and do 10 question. Submit to me next lecture. I don't have time to go back to cover the mathematics. You can't pass this module if you don't know how to do differentiation. I don't want to see you next semester. Y equal to a 2x squared. Dy dx. You continue the constant value. You differentiate the x square, you get 2x. You get 4x. Dy dx square, what do? You continue with this one. So what do you get if you differentiate 4x? Why 4? Why 4 and not continue to use 4x? What mean by x power 0? Okay. Then back to this tutorial question, example 1. What is the double differentiation for this 1 over 10x? Huh? You can do this one, you cannot do this one. You cannot, you can do dy dx equal to 4x. The double differentiation, you get 4. You can do this one, you cannot do this one. Answer is 1 over 10. Yeah, you owe me 10 question differentiation question exercise. You go and pick 10 question, you do, then show me. Okay, so dy dx equal to 1 over 10x. You can substitute your x value in that particular time, your x equal to 10. So when you substitute dy dx equal to 1 over 10, substitute 10, because at that particular position, your x location is 10, you get 1. Then, what is dy dx? It actually is a tangent. Can you see why is a tangent, Nico? Why suddenly on the screen here, I can represent dy dx equal to 10 theta? Why? What is the gradient? What is the gradient if you find straight line? What is the gradient of this point? If this point on the dy dx, I'm writing something on the white screen, those watching online. On this point, how to find gradient? This is y equal to mx plus c. How to find your m? Okay, so you take dy dx. So at that particular point, there's an angle, trigonometry, tangent. Again, A, B, C. What is the tangent theta for this right angle triangular? You have A, B, and C. Which divided by which one? Tangent, A over B. So in this case, what A over B? Because your A is y component, B is x component. This is a triangular. So dy, this is y component divided by the x. So tangent equal 1. This angle, you get one equation, tangent equal 1. You flip, you want to find the angle, you flip, you get transpose of 1. Go and learn how to press your calculator, because there are some students, when they come here, they stuck. They don't know how to press calculator, right? So tangent 1 is a known value, is 45. Okay. Then you have all these value, 6, VA equal to 6. So your V, your VA 6 meter per second, where is the direction? This is the magnitude. VA 6 meter per second is the magnitude. Direction is 45 degree going down. This bold line here is your x direction. X-axis is 45 degree go down from the horizontal position. Make sense? Yeah. Okay, we have find the V direction. Now go to the acceleration. Acceleration, go back to these slides. You can find the AT and AN. Okay, I don't need to repeat this one. So go straight away. You apply these slides into your solution. Again, go back to your free body diagram. A equal to V naught ut plus V square divided by rho un. You have the Vt. The VA actually is a Vt, tangent component velocity. And acceleration was given in a tangent component, right? So you draw your AN. AN is this one. Okay. So you have AN and AT and AN, they form a vector. To find a resultant, this is the way you form a vector. So to find the resultant is this one square, AN square plus AT square square root. You get A. Okay, the rest is substitution. So you pull back the curvature of the curve equation, or R, you get this one. You already do the differentiation. You substitute inside. You simplify. You get one equation, because you still have x inside. Rho equal to something x. Then you substitute at that particular position. Where is your x? Your x is 10. Still remember? Yeah, because your x location is 10. Yeah. So you substitute inside there, you get the answer for your curvature curve. And don't to differentiate from the velocity and the acceleration, I use this symbol. to represent the angle for your acceleration. Okay, yeah, okay. Or you can use theta sub v or theta sub a also can. Okay, you get your rho 38 point something, but again, the number is not important. Important is the steps, how we solve. Okay, once we have that, we just substitute the value inside. You have A equal to V naught ut plus V square over rho un. You have your acceleration. V dot means acceleration. You have 2. V square, you have 6. And then rho you defined just now, 28 something. So be careful in your calculation because it's always snowballing. If you calculate wrong in the curvature, then the rest is also wrong. Because you are recycling the number. Okay, so then you calculate, you get one vector form. A equal to 2 something plus 1.2 something. One is in tangent, one is in normal. You need to find the resultant acceleration. So resultant acceleration, you square plus square root. You get the resultant A equal to 2.3. Okay. Then how to find the angle? Again, trigonometry. On the screen here, you see there's a rectangular. This rectangular right angle. This is your AT, this is your AN. Angle over here is your angle. So tangent, opposite, and side. Opposite is 2. Side is 1.2 something. Make sense? Press your calculator, do the inverse, you get the angle. This angle referring to where? Referring to normal direction. Okay. So you need to do calculation. This is from the horizon. You get this angle, 90 degree. The balance is here, and then you need to do some calculation. There's a calculation there, right? Okay. Okay, I do the working for you already. Go find out why it can be 12.5. Working is on the screen. Okay. Example 11. Let's example number 11. Okay, so this one come up many times in my assessment question. Okay, I love ask you about curvature motion. Right, so pay attention. So there's a car moving along a circular track. Radius of 300 meter. Radius is given now. So if the car increase its speed at a constant rate, 1.5 meter per second, it gives you the constant rate now. Starting from rest, you know that your V starting is 0. Determine the speed, the time needed to reach acceleration of 2. We ask you about acceleration and not velocity. In your static module, you will be asked velocity, but it comes to engine dynamics, most of the time we ask you acceleration. So don't carry something that you're familiar in static, you do, then you apply in dynamics. Look carefully on the question, what the question asks you. So what is the speed at this instant? So it asks you back the velocity. Okay, first, you look at the diagram. Again, first steps, repeat the same procedure. Draw normal tangent direction. Okay, you understand why normal pointing in? Yeah, curve pointing in. Tangent always 90 degree to the curve. Once you do the normal tangent, you label the position. So AT, AN. Why you use AT and not velocity? Because it was given in the question. You are given acceleration. So you have AT. Okay. So how do you find an again? How do you find an? V square divided by rho. You have the rho, you have the radius. You need to find the Vt. Okay. So again, once you have a vector, always remember that you need to find resultant. Don't stop there. Coordinate system, AT positive, and so on. So acceleration, AT given 1.5. AN you can find from this formula, V squared divided by rho. So again, you are being told one hint is that acceleration is constant. So pull the three famous equation. So you want to find velocity, pull the velocity. And you want to find time. So this is the equation that straight away give you what you want. V equal to V O plus AT T. You know starting from rest. So this one 0. Acceleration given 1.5 constant and time. So you get one linear equation here. All right. So you get one equation, and you have acceleration here. So acceleration normal equal to V squared divided by rho. This is your Vt. Substitute this one inside here. Your A will be in terms of time. Again, this is mathematics. You just substitute. Substitute inside there. Rho, you know, the radius, you know, 300. Then you simplify the equation, right? So you have two components, AT and AN. Make sense? How to find resultant? Square the AT plus square the AN, square root. Substitute inside, you still have one time there. This is mathematics. Here to here is mathematics. Careless mistakes always we found is you forget to carry your square inside here. You will do, and then you suddenly the square missing. You will do the square root, but you will carry 1.5 here, 1.5 t square here inside, but you forget there's a square there. Then you get the wrong answer. Okay, so the resultant is 2. Because you want to find the resultant when it reaches acceleration of 2 meters per second squared. So this is the acceleration that you are focusing on. When you read the question, the acceleration do not tell you whether it's tangent, whether it's moving tangent to the curve. Then it is a resultant acceleration. It is the A that you want to find. You complete the solution, you're able to find your time because only one unknown there. All right. Okay. So again, when you square root, you have positive, negative answer. Get the positive t. Okay. The homework to find this one, the t. Reference answer is 13.28 second. For this module, minimum 2 decimal place, maximum 3 decimal place. What is the speed? The speed, you define one equation for the velocity. V equal to 1.5, substitute this inside there, you get the velocity. Okay. Now again, recap before we stop for the break. Recap, we are always repeating the same procedure in example 10 and 11. First, what you do, you draw the axis, normal, tangent. Then, in the empty space, you write the two equations. One is A equal to tangent component plus normal component. This one, you write this one. And then you, to remind yourself that actually there's an equation to find the radius, you write this radius equation. So automatically, if you write this one and this one in your answer, if the question already give you radius, then you know this, you know that you don't need this one. But if the radius is not given, then you need this one. All these are free marks, huh? All these are free marks. And the normal tangent on your graph also have marks. So by looking at the way we give you marks, if you draw the correct axis, normal tangent, you already have 2 marks already. The equation, this one already 2 marks, so 4 marks already. If the question do not give you radius, you have another 2 marks, so 6 marks already. Out of 25, you have 6 free marks there. So very easy to score one. It's very hard to fail in my module one, unless you really panic, you don't know what to do. Okay, number 12 is what you'll see when you graduate. You will be asked to go to the factory floor and design something. So 12, the box travel along this conveyor. This is called conveyor. So it move and then turn. The question actually interests in this area. Why? This one linear, no problem. But this is curvilinear motion. This have a curve. So along conveyor, if the box start at rest, again, it give you the initial velocity at A and increase speed A t equal to 0.2 t. Determine the magnitude of acceleration when you arrive at B. Okay, so you're given all this information. Here, straight line to here is 3 meter. There's a curvature of 2 meter. A radius here. So you know when radius given, you can save the radius equation already. Means you don't need this equation. Huh? Okay. So there's a A, there's a B there. You want to find magnitude of acceleration when you arrive at point B. Okay? Want to find this one. So basically, when you come to your test or exam, this is what you will see. Give you a picture, give you location A, location B, and then there's some statement, and then you work it out. You will see 3 sections. A will ask you to draw free body diagram. B will ask you to solve something. C will ask you what is the direction, what does it mean, or predict the motion, whether it continue to move or move back, like so. Okay. So again, first draw normal tangent at point B, because point B is what we're interested in. So normal always pointing in, tangent always follow the motion, right? Coordinate system. Then acceleration. Start at rest. How to find acceleration? You have AT. Rest and then increase to speed as when it start at rest and then it increase the speed that AT equal to 0.2 t. So here 0. You start with the acceleration 0.2 t. What equation you can use from here to here? Nico, what equation you can use? Why? Why you use that one? Ah. Then which one? Is equal. You know that there's a 3 equation you can use, right? So which one? What's the full equation? What's your full equation? What is your equation you use? No, you have three equations, right? V equals something, S equals something, V squared over something. Which one you use? 1 second. Then also, if you want to use that one, but why you use second? You can use second. You are making yourself more work to do. Okay, so you have these two equations, these two parameter. V you have, AT you have. Definition of AT equal to dV dt. So you have this one, 0.2 t dV dt. What is the equation for derive this equation into V equation, Nico? How you do? How to get your V equation? Yeah, how? What is the answer? If you cannot answer, you add 10 more questions for integration. I'm not joking, huh? How do you do integration? How you get V equation? What's the rules in mathematics? You do arrangement. How you do arrangement? How you pack your thing? How you pack? It's quite messy here. How you pack? Okay, 0.2 t dt equal dv. You have dt and dv. What's the next steps? Differentiate. Integrate 0.2 t dt. Integrate dv. This one t. Integrate lower limit is what? T0. You start from 0. So velocity also start with vt equals 0. You know this one is what? When they start 0. It tell you it start from rest. So you need to find the time to reach at the certain position. You integrate this one, because you have the limit, you don't have the constant value. If not, then you have a plus c in the equation. Okay, here you get one equation there. I'll show you on the screen. dV dt, you integrate like what I write on the screen. You arrive v equal to 0.1 t squared. How to get 0.1 t squared, Nico? Yeah, why? How? What's the next step from here? Yeah. 0.2 t become what? Over what? T become what? Square, then over what? Over half. Is this what you mean? Over half? Over what? y2. X plus the general equation n okay, so that's why you get 0.1 t squared. Once you have one equation for v, you can find the rest. So you know that the definition of v equal to dsdt. You find previously v equal to 0.1 t. Repeat the same process, you can find the s equation. Right? Nickel, find the equation for s from here. What is the s equal to? No, continue from here. I'm asking you. Previously, is v equal to something. Now, I want you to solve for s. What is the displacement equation? You don't look at the whiteboard. You're looking at the whiteboard won't help you. Write something and then you can write on your piece of paper, then tell me. What is your s? Yeah. Tell me the final answer. Okay, v equal to dsdt equal to 0.1 t squared. How to find the s equation? Okay, you're given maybe 2 minutes to solve. It's a very simple equation. The sample already given on the top of the slides. You should be able to do. S equal 0.1 t 0.1 t squared over 2. Agree? What's your answer? What's your answer? Do you agree? Do you agree? What do you get? 0.2 t cube. Nico, next lecture, your homework, So 10 question, dy dx question, 10 question integration question. Submit next lecture. You will get 0.1 divided by 3 t cube. How you get 0.2 just now?
I use 0.2 T.
Okay, so the answer for S equation at when it reach B, right, will be 0.1 T, 0.1 divided by 3 T cube TB, huh? Okay, you have two equations. Are you able to find the distance when it reach B location? It's a circular circle question. So here you get 3. This is a quarter circle. Circle radius or circle circumference is 2 pi r. You only have quarter, so 1 quarter. You get 6 point something meter when you reach B. Okay. So you substitute this one inside here. SB equal to 6 something into the equation you find. You can find your TB. Okay, T 5 point something second. Again, once you have time, you substitute back here. V equal to 0.1 T square. Substitute here, you get your V, 3 point something when you reach B. Okay. Then you substitute again, you find your A because you have T already. AT equal to 0.2 T, you have the time already. Okay. Then you have AT 1 point something. How to find AN? AN equal to V square over rho. Rho you're given to V you already find just now. Because it's a tangent component. You find your AN. Substitute value, you find your AN. You have your AT-AN, you can find resultant of acceleration. Square this one plus square this one, square root, you get AN. A answer is 5.36. Where is the direction of I? Okay, so here you have normal and tangent. Direction, all right. Okay, so okay, we will continue after the break. Okay, we stop here. We come back 9:10, 5 minutes break. Okay, 9:10.